If you manage only two things in hydroponics, manage pH and EC, get these right and most of the problems solve themselves. Get them wrong, and even a perfect nutrient formula won't help. Let's start with pH. The term stands for potential of hydrogen. It's a measure how acidic or alkaline a solution is on a scale from 0 to 14. 7 is neutral, below 7 is acidic, above 7 is alkaline. Why does this matter? Because pH affects nutrient solubility. Most hydroponic nutrients are only available to plants within a narrow pH range, typically between 5.5 and 6.5. Outside this range, nutrients can precipitate out of solution or become chemically bound in forms the plant can't absorb. For example, iron is readily available at low pH but becomes unavailable above pH 7. Phosphorus is most available between 6 and 7 but can precipitate with calcium at higher pH levels. If your pH drifts too high, you might see iron deficiency even though there's plenty of iron in the solution. The plant just can't access it. pH in hydroponics is not stable. As plants absorb nutrients, they release hydrogen ions or hydroxide ions, which shift the pH. Some nutrients, like ammonium, lower pH when absorbed. Others, like nitrate, raise it. Environmental factors like temperature and CO2 levels also influence pH. This is why growers check pH daily and adjust it as needed. pH is adjusted using acids to lower it or bases to raise it. Phosphoric acid and nitric acid are common pH-down solutions. Potassium hydroxide or potassium carbonate are used to raise pH. Adjustments are made in small increments because overcorrecting causes wild swings that stress the plant. Now let's talk about EC or electrical conductivity. This measures the total concentration of dissolved salts in the water. Hydroponic nutrients are salts. When they dissolve, they create ions that conduct electricity. The more concentrated the solution, the higher the conductivity. EC is measured in millisiemens per centimeter or microsiemens. Different crops have different ideal EC ranges. Lettuce, for example, grows well at 1.2 to 1.8 millisiemens. Tomatoes prefer 2.0 to 3.5. Seedlings need lower EC than mature plants. If EC is too low, the plant doesn't get enough nutrients. Growth slows and deficiency symptoms appear. If EC is too high, the solution is too concentrated. This creates osmotic stress. The plant struggles to absorb water because the water outside the roots has a higher solute concentration than the water inside. In extreme cases, this pulls water out of the plant, causing wilting even though the roots are submerged. EC also changes over time. As plants absorb water and nutrients, they don't absorb them at the same rate. On a hot day, a plant might take up a lot of water, but fewer nutrients. This concentrates the solution and raises EC. On a cool day, the plant might absorb more nutrients relative to water, which lowers EC. Evaporation from the reservoir also concentrates the solution. This is why growers monitor EC daily and top up the reservoir with either plain water or diluted nutrient solution to keep EC in range. Some systems use automated dosing pumps that adjust EC in real time. pH and EC are interconnected. Adjusting pH can change EC slightly because the acids and bases used are themselves salts, and changes in nutrient concentration affect buffering capacity, which influences how stable the pH remains. The key is consistency. Check pH and EC at the same time each day. Log the values. Watch for trends. If pH keeps drifting up, there's a reason. If EC keeps climbing, the plant isn't drinking enough or evaporation is too high. These measurements tell you what's happening in the root zone. They're your early warning system.